Good afternoon, everyone. My name is Dr. M. Nagaraju, Assistant Professor, Institute of Aeronautical Engineering, Department of Computer Science and Engineering, Artificial Intelligence and Machine Learning. Today, I am here to express my lecture on a specific topic called as knowledge representation. This concept is a continuation topic to the introduction to artificial intelligence, which I have taught you in the earlier session. So, before moving into this one, it's better to recap that session once again. Why? Because we are going to take some of the information which we have discussed in that lecture, so that it will be very easy to understand here. Okay, so here directly we will jump into the topic. The topic name itself is a knowledge representation. One particular way of representing facts is the language of logic. So here, before trying to understand what the language of logic means, so first of all, we will try to concentrate little bit on the same word which is called as knowledge. Okay, in the problem of artificial intelligence, already we told during the problem solving, being the humans or being the machines, they require the knowledge. Means once they represent the knowledge in a proper way, definitely they could able to solve any kind of problems. Means the primary and the most important thing required for a human being or a AI machine is, if we could able to represent the knowledge in a proper way, then it will be very easy to apply it and exhibit some kind of intelligence. Similar to that one, here we are going to concentrate now on a particular topic called as knowledge representation. So why we require the knowledge representation, means why we need to concentrate on this particular aspect. As we know that being the human beings, right, we could able to understand different kinds of languages. Means whenever some people write some kind of sentences, with that easily we could able to understand what that sentence is actually telling. But is it the case with the machines? Why? Because during the time of problem solving, we are going to develop this knowledge, or we are going to represent this knowledge not for the human's purpose, but we need to feed this knowledge representation to the AI machine, so that the AI machine can understand this knowledge and it can exhibit its behavior. Exhibiting the behavior is nothing but solving some kind of problems. Means whenever the artificial intelligence machine is in a stage to understand the way how we understand the knowledge what we have represented, then the remaining things will go smoothly. That's why we need to concentrate a lot on this particular aspect called as knowledge representation. So how we need to represent the knowledge? Generally, being the humans, we take the help of a language, a common language which is called as English. Okay, through English language, we could easily able to represent the knowledge. Okay, for example, if today is raining, simply I can represent a statement saying that it is raining. I can say that simply it is raining. For example, if the temperature is cold, so I can say that I can represent the knowledge in the simple words using English like this. The temperature is too cool today, or otherwise too cold today. Means by the English language, what we know, it is very easy to represent the knowledge. But here we are concentrating on the knowledge representation, or representing the knowledge that we are not going to use. But what happens here? This knowledge, we need knowledge representation, or this knowledge we need to feed it to an AI machine here. We need to feed it to the AI machine. So in this case, whatever the way, means whatever the approach or whatever the process we are following to represent this knowledge and make it understand, so this kind of things will not work when we are dealing with the machines. So a different kind of knowledge representation should be there, so that even the knowledge represented by the humans can also be understood by the machines during their problem solving. Okay, so how can we do it? Means how can we represent the knowledge in such a way that even the machines can also understand? My today's lecture is totally going to concentrate on this aspect called as knowledge representation. Means we need to represent the knowledge in a different way. So in a different way is nothing but here using some kind of logic and represent the same English representations into a machine related representations, and that we can give it to the machine to solve the problems. So knowledge representation is a major criteria now. So what are the first most important thing we require during the time of knowledge representation is we need to have, or we need to select some formal language. We need to select some formal language. There should be a knowledge, there should be some language. Already we know that even for doing communication with other humans, we also require some kind of a language. Similar to that one, in order to represent this knowledge, definitely we need to have one particular language. So I am calling that language as a formal language. Why I am saying it as formal language means this language is going to include, or it is going to implement certain kind of logic during the time of representing the knowledge. Means the first step we have to do while doing the knowledge representation is we have to select a specific language which is called as formal language. During the sessions and today's session and the continuous session, we are going to discuss about two different kinds of formal languages, or we can say that some logic kind of languages. One is called as propositional logic. One is called as propositional logic, and another one is called as predicate logic. One is called as predicate logic. Means these are the two formal languages which we are going to select while representing the knowledge. Remember, this formal language is we are using to represent the knowledge. Okay, let us consider that by using this formal language, you have represented the knowledge. Until and unless you don't know how to use it, then it is a waste of representing such kind of knowledge. So what we have to do is, in the next step, we need to understand, or we need to know what are the different methods that can be used or that can be applicable in order to use this knowledge. So in the second step, we need to concentrate on a specific thing called as method to use the knowledge. Okay, method to use the knowledge. And then after, we need to think about some inference mechanisms. We need to think about some inference mechanism. So here, what do you mean by these inference mechanisms? See, what happened in the first most step, you have selected some language and you have represented some knowledge. In the second step, you learned how to use it. But using of this knowledge does not mean that you are getting some kind of solutions to the problems. Until and unless you could able to get some inferences, means if you could able to get to a specific conclusion while using this representation, then we can say that we have succeeded in that aspect. So inference mechanism is nothing but applying some kind of logic rules or logical rules, we can say. Applying some kind of logical rules, right, to the facts that we have represented in the knowledge. Or otherwise we can say we are going to apply these logical rules to the facts which we have represented in the knowledge base. So here knowledge base is nothing but it is a database. We can say it is a database which is going to have some facts and some rules. So what we are doing with the help of these logical rules, we are applying these logical rules to the facts. So what this is going to give? This is going to give some new information, or we can say it is going to give some new knowledge to us. New knowledge is nothing but extracting some new structures. New structures are of the same knowledge, remember, of the same knowledge. So what we do with these new structures, we are going to use these new structures in order to get some kind of solutions. Okay, in order to get some kind of solutions to the problems what we have. Okay, means we are discussing all these important points in only to do the problem solving. Means when it is possible to do it, means whenever you could able to apply some sort of inference mechanisms, and if you could able to generate new structures, then only it is possible. Why? Because the new structures are going to make you are going to get some kind of solutions, or some, we can say, a path which you can use it in order to get the solutions to the problems what we have. Okay, so that is a major third important thing we require when we are doing knowledge representation. Okay, right. Let us come back and we will discuss about this formal language. As I mentioned, formal language is definitely required. Means where you are going to apply some sort of logic during the time of representing the knowledge. Remember, until and unless there is some kind of logic in the knowledge representation, then you cannot use that knowledge in order to solve the problems what you have. Means here even the AI machine also, right? When it comes to AI machine also could able to give the answers whenever there is some kind of logic that exists in the knowledge. Let us take one simple example. In the knowledge representation, think that you have represented a knowledge saying that it is raining. So this is the knowledge you have given, but you didn't apply any logical rules, or you didn't applied any language related things to this one. So you have given this one to the artificial intelligence machine, and you have asked the question saying it as why it is raining. Why it is raining. So definitely, right, as we are feeding the artificial intelligence machine only with a specific knowledge, that is it is raining, then the AI machine cannot able to understand this particular question, why it is raining. That's why it will not be in a stage to give the answers to this one. Means just having a knowledge with you is not enough, right, in order to give some kind of inferences. Means in order to get some inferences, you should not come to a conclusion to solve the problems with these kind of statements. So what you have to do is you need to follow all these kind of things. Means selecting the formal language is not a big matter. Of course, you can select either a propositional logic or it can be a predicate logic. But if you could not able to mention two different things, so what are there? One is called as syntax and another one is called as semantics. Syntax and semantics. Right, as we know that any kind of language you take, right, definitely that knowledge, that language, means whenever you are using that language, definitely you have to follow some syntax and some semantics. If we talk about the syntax, then we can say that it is kind of a grammar. It is a kind of grammar we need to follow in order to represent that knowledge. Okay, so here what I am doing, I am writing the same sentence, that is it is raining. I am following some kind of grammar and I am representing the statement saying it is raining. That means that I am following the grammar which is related to a particular language. Of course, this is a English language representation. Of course, we are going to see how we can represent this English language representation into formal language representation. But I want to tell you only how we are going to represent. Means in this particular case, I can say that we have followed proper grammar. Means in the formal language also, you need to first of all write the representations in such a way that the syntax should be correct. Means the grammar should be correct while representing the knowledge, and also the semantics. So here, what do you mean by the semantics here? Semantics is nothing but some kind of meaning. Semantics is nothing but some kind of meaning. So whenever I mention this particular statement, it is raining, then simply I can say that we can come to a conclusion. Means we can easily able to understand what that sentence is telling all about. It is raining. Of course, some raining is going outside. Raining is happening outside. Okay. So what about the meaning? The meaning is also very good. For example, think that I have represented one more statement which is called as pen has cut the road. Okay, pen has cut the road. So here what is happening? Am I following the syntax while representing this knowledge? So definitely I can say that yes. I can say yes. Okay, means as per the grammar. Okay, as per the grammar point of view, I have represented in a correct way only. But when it comes to the meaning, right? Is this statement is having any meaning? How can we say that with the help of a pen we can cut the road? Is it possible? It is not possible. So that means that in this particular case you have followed the grammar, but you didn't follow the meaning. While representing the knowledge, you have to see in such a way that you have to represent the knowledge, or we need to represent some English sentences which should have both the syntax as well as the semantics. Okay, so let us try to understand how this syntax and semantics can be implemented or can be used while representing some sentences with the help of this formal language. So we will try to stick on to our explanation at present on the propositional logic. Okay, propositional logic is nothing but it is a kind of formal language which is going to implement some logic. Means we can say that it is the propositional logic is a language of logic. Language of logic. So what is propositional logic consists of? Okay, we need to understand what is propositional logic consists of. So propositional logic, we can say that this is a particular language we are going to select in order to represent the knowledge. Okay, in order to represent the knowledge in the form of propositions. In the form of some propositions. So what do you mean by a proposition? So whatever you represent in the in English, so everything we can say that it is a proposition. Means if I write some kind of sentence, for example, if I write the same example, that is, it is raining. Okay, it is raining, or otherwise I can say that I am teaching. I am teaching. Okay, similarly I can say that the students are listening. The students are listening. So these kind of sentences I can say that these are the propositions. These are the propositions. But of course, we can you may get a doubt that sir, you have represented these things in the English, and how can we say that these are the propositions? See, propositions are nothing but some kind of sentences, or we can say they are the declarative sentences, right, which are going to represent certain kind of English statements. It is going to represent certain kind of English statements. But in propositional logic, what we are doing is we are going to change these things. Means we are going to represent these kind of sentences. Okay, we are going to represent these kind of sentences with the help of some variables. With the help of some variables. So simply, it is raining, I can represent with a variable called as P. Similar to that one, I can represent I am teaching in the form with a variable Q, and the students are listening, some variable R. So if you could able to implement the inference mechanism here, you can easily extract new knowledge from these sentences. So how can I do it? Let us try to check these two. Means we can extract or we can generate new knowledge by combining the existing knowledge. So what are the existing knowledges we have? 1, 2, 3. You try to frame. Means here, whenever you are trying to extract new knowledge from the existing one, you need to once again think of the syntax and the semantics. Okay, let us try to combine 1 and 2, and we will see whether it is following the syntax and semantics or not. How can I do it? So I will write like this. It is raining. It is raining and I am teaching. It is raining and I am teaching. So is it sentence? Is this sentence or is this representation giving any kind of meaning? Of course, it is as per the grammar itself. Means we are following the syntax while representing this. But what about the meaning, semantics? We are not following any kind of semantics in this case. So we cannot combine the two propositions, means 1 and 2 propositions, to generate the new proposition here. So what I can do, I can able to combine this 2 and 3. How it will be? So I can write like this. I am teaching. Okay, I am teaching and the students are listening. I am teaching and the students are listening. This third sentence, what means this fourth sentence, whatever we generated now, they are exactly matching or they are exactly following the syntax as well as semantics. How can I say? Okay, syntactically it may be correct, but grammatically means or semantically, how can I say that this representation is correct representation? You try to observe this one. This sentence, this complete sentence is talking about only one particular world. What is that world? About a classroom. I am talking about a classroom. Means the sentence I am teaching is the sentence. It is talking about the world classroom, and the students are listening is also belongs to the world classroom. So what I have done here, two sentences or two representations which belongs to the same world, I have combined together and generated the new sentence, or I have given a new representation. Then we can say that we have applied inference mechanisms here. If you talk about in terms of prepositional logic, so I can say like this. So this representation, it will be P, and in place of and, I can write like this: P and, sorry, it is not P and, it is Q and. Okay, Q and R. What the Q is representing, I am teaching, and what the R is representing here, the students are listening. So this one, if I convert into propositional logic, so what I have to do is I need to use some kind of connectors. Some kind of connectors. Here, what is the connector here? And is the connector which is connecting these both sentences, these both representations. So in place of and, I am going to write in this way: Q and or. It is called as logical operator. Logical operator and, or otherwise we can say that it is a connector. Means in the propositional logic, the sentences or the declarative statements can be individual, or they can be formed with the help of some multiple statements. So in that case, we say that it is a compound propositional logic or compound propositional statement. Why? Because it is having multiple propositions here. This is one proposition and this is another proposition. If we talk about the point of elements, means different elements of this propositional logic, how it will be, you see, if it is, if I say that James is hardworking. James is hardworking. If I say this statement, James is hardworking, so I can represent in the propositional logic with some kind of variable. But we need to understand what this James is all about and what this hardworking is all about. That is nothing but the elements of a proposition. So here in this case, we say that James is a object. We can say James is a object, and hardworking, it will becomes the relation. It will become the relation, or it can be considered as a function. Function here, it is nothing but some subset of the relation. Okay, means in the propositional logic, we are going to represent the statements or some declarative statements, or we can say some logical statements in the form of some variables and in the form of some connectors. Okay, so we can say that we can say that symbolic variables, with the help of some symbolic variables, and also with the form of some symbols. Okay, symbols here nothing but some kind of connectors. It is some kind of connectors. Let us take some more examples and we will try to understand how these propositions or propositional logic is helpful in representing the knowledge in the formal way. Let us consider some examples to understand more clearly how this propositional logic can be implemented. Okay, I will take a sentence, or I will take a representation saying that James is intelligent, or we can say James is James is intelligent. And similar to that one, there is one more statement is also there, which is representing the same state of world about the James itself. So James is hardworking. James is hardworking. So these are the two statements are there. Already I mentioned these sentences or these representations we can represent with the help of some variables also. So if I represent that one, this sentence as P and this sentence as Q, then we need to apply some inference mechanisms and we have to generate some new knowledge. New knowledge is itself is going to give us some kind of solutions to the problems. Why? Because just representing these two sentences will not give that much support to the artificial intelligence machine to think and to give the answers to the questions we frame. So we will try to create new knowledge to this one. But before creating the knowledge, we need to understand how these sentences can be represented with the help of some propositional logic. So we will try to concentrate on this one. So if I add these two sentences, how can I add it? Just now we have seen one example, right? Here I am saying it as James is intelligent. Okay, James is intelligent, and at the same time, and James is hardworking. James is hardworking. So how can we represent with the help of variables? So I can say that P and Q. Logical operator P and Q. So what will be the outputs for this one? Means why? Because you need to get the conclusion with this statement. In the propositional logic, all the statements, all the declarative statements are going to give only two possible answers. Or we can say that only two possible outputs. Either it can be true or it can be false. If I say it is raining, really if it is raining, then we can say that it is true. If you really represented it is raining in the knowledge base, then it is true. We can represent it as true. Why? Because in the knowledge base you have represented the same sentence. Okay, similar to that one, here what I have done, I have represented these two sentences with the help of some variables. Okay, so what is the answer for these two things? Okay, for example, if you see this one P, what will be the output for this preposition? James is intelligent. So in the knowledge base, what you have represented? James is intelligent. Okay, so that means that it will be true. It is true. Okay, in the similar way, Q also. What you have used Q for representing the statement saying it as James is hardworking. Okay, so this will also become true. Means what is happening here? You are applying a connector or a logical operator between true and true. Whenever you do like this, the output you are going to get is true. Let us take one more example. It is raining. It is raining. Right? So what I have done, let us think that I have taken R to represent this statement. It is raining. Okay, so how should I represent this one? Means if it is raining, really, definitely you are going to get some output true. Okay, for example, if I change this sentence, means instead of writing it is raining, I am going to say raining, I am going to say it is not raining. It is not raining. So what happened? For it is raining, I have represented R. So in this case, what should I do? I should use another symbol which is called as not. Okay, not R. So what is the meaning of this one? Not R means not raining. Means this proposition logic representation is telling all about this particular sentence. What is that? It is not raining. If it is raining, just we mention it as R. As we have used a specific word called as not, to represent this not, we are using this symbol. Okay, now you try to frame the answer for this one. As it is raining, so what you have done, you have mentioned it as true. If it is not raining means it is not true. If it is not true, then obviously it will be false. Okay, we need to think more about these representations. Why? Because these are definitely going to be helpful for you in the understanding of coming topics. I will take one more example for your better understanding. What is that? Here I am using one. It is raining. It is raining. It is one sentence, and I can say that the roads are wet. The roads are wet. These are the two sentences we have, two representations we can say. How can we generate the new representation from this one? So I can write like this, the same way. Okay, how we used for James is intelligent and James is hardworking. Just like that, here I am adding the connector. I am using a connector. What is that? And is the connector. So it is raining. It is raining, and the roads are wet. So first of all, try to understand whether we followed the syntax and semantics of the formal language. Definitely we can say yes. Why? Because these two sentences are talking about the same world, that is temperature, some environment, climatic conditions. Okay, so we have followed the syntax and also we have followed the semantics. Means the sentence is giving some kind of sense, some meaning. Okay, so again, if it is P and if it is Q, so what happens? It will becomes P and Q. It will become P and Q. So again, the same thing, true and true. Okay, so it is true and true. Then the output will be true. Let us do some experiment on this statement. Okay, what is that experiment? So I am writing like this. What is it? Okay. The roads are wet. The roads are wet and it is raining. It is raining. So in this case, what happened? Right, when it is true and true, you can represent like this also. Means it's not necessary. Means just in the general representation, you can frame P and Q. But here, what happened? True and true. So I can represent with the implies also. P implies Q. Means whenever P is true, then obviously Q is also going to be true. Means if it is raining, as it is raining, then we can say that because of this raining reason, the roads are wet. It is giving some meaning. So I am representing that one in the propositional logic like this. P implies Q. Means when P is Q, then obviously or automatically Q will becomes true. So similar to that one, can I say like this? Means can I write Q implies P? For this one only, I am taking this example. The roads are wet and it is raining. The roads are wet, we have represented with Q. Okay, means we have represented with Q and we are saying this one. Means what it means? Because of this reason. What is the reason? Because the roads are wet. Okay, means the reason for this wetness of the roads is because of the raining. But really, is it going to be true? Definitely not. Okay, maybe or may not be. Why? Because there is another chance for wetting of these roads. Roads can be wet because of the other reasons, like if somebody is pouring some water on the road, right? Or otherwise some sprinklers are used and make that roads wet. Means there may be some other reasons for this particular case. So I cannot simply say that Q implies P. Okay, so whenever the P implies Q, means whenever the P implies Q, it does not mean that every time Q also need to imply P. Implies P. So when can I say that one? When can I say that P implies is Q and also Q implies P? When can I use this statement? So I can write the same thing. We can take this particular example. Okay, so how I am writing here, you see the same thing. James is intelligent and James is hardworking. So in this case, what is happening? I can write like this: P implies Q. As the James is intelligent, so we can say that because of how he got the intelligence, because he is hardworking. What happens if I shuffle the statements? Means what happens if I write James is hardworking first and then James is intelligent? Nothing is going to happen. Means we are not going to disturb the semantics of the representation. How it will be after shuffling? James is hardworking and James is intelligent. Because of his hardworking, he is intelligent. In some kind of meaning, it is giving some kind of meaning. So in that case, what is happening? When I am shuffling the statements, I can represent like this also. Q implies P. As the P implies Q, Q also implied P in this particular example. Of course, it will not be possible. It is not possible in every case. But in this example, it is possible. Okay, it became possible. So instead of using these two representations, I can use like this. P double implies Q. That means that P implies Q as well as Q implies P. Okay. So with the help of this complete explanation, and the knowledge we gained up to now, simply we can say that for representing the facts, we need to have a certain kind of language which is called as a formal language, and also we say that it is a language of logic. Language of logic means here either it can be a propositional logic or it can be a predicate logic. But what we are doing, you are using or you are trying to apply some kind of logic to come to a conclusion. Nothing but you are trying to extract some kind of inferences. Okay, until and unless you apply logic, you cannot able to get some inferences. You cannot come to a conclusion, or you cannot get a solution to a specific problem. Okay, so it immediately suggests, means what the language of logic is telling all about. It is going to suggest a powerful way of deriving new knowledge. Just now we talked. Deriving of new knowledge, it is completely going to depend upon the logic you are going to apply. So how can we apply this logic? By the help of the formal languages. Means the predicate logic and the propositional logic, they are going to support us in order to feed or in order to implement or in order to use this logic and to get some new knowledge from the existing one. Okay, even we can say that it is a kind of mathematical deduction. It can conclude that a new statement is true by providing the statements that are already known. Just now we have seen one particular example. James is intelligent and James is hardworking. Okay, with these two sentences, I can write one more inference also. Okay, so one more proposition also I can write. How it will be? If James is, okay, I am generating the new knowledge from the existing knowledge. Okay, what is that? If James is hardworking, and James is intelligent, then I am applying the logic here. What is that logic? If then kind of condition based logic. Okay, so if James is hardworking and James is intelligent, then James can, of course you can refine this sentence, but for your understanding I am writing like this. Okay, James is intelligent and James can achieve or get a higher package. I can write like this: higher package job. So here what is happening, right? I am writing this particular sentence by taking the help of the existing sentences. So what I am doing, I am coming to a conclusion. Means what this propositional logic helped us? In what way? Means it helped us in order to extract these kind of new knowledges from the existing one. So obviously, as these two are true, then definitely the next one is also going to be true. Why? Because already these two sentences has proven that they are the true sentences, are true representations. Then definitely whenever you are generating the new knowledge from the existing one, it is also going to be true. That's why we say every time that the propositional logic is going to give only two kinds of answers, like 0 or 1, or true or false. If I say it is raining, you may say yes or no. If I say you are listening, you may say yes or no. Means in each and every kind of representation in propositions, means in terms of propositions, then the result can be either true or false. Okay, we can say that means using of this propositional logic or predicate knowledge logic is nothing but some extension. Means we are trying to give some kind of extension to the already existing one. So we know that logic theorist, which is a artificial intelligence program, which is going to help us in solving some mathematical theorems. Okay, some mathematical theorems we can solve with the help of this logic theorist. Similar to that one, there is one more artificial intelligence program which is called as theorem prover. Okay, this is going to help us in in solving the geometry kind of problems. So using or implementing this propositional logic and the predicate knowledge logic is nothing but going forward or extending the knowledge in proving the mathematical kind of problems. Of course, we know that all these things are already done in the late 1980s and in the early 1950s itself. Okay, so with this mathematical kind of things, what we are doing, we are trying to extend. Okay, we are trying to extend the already existing research. Okay, already existing research in a particular level. So what is that particular level here? We are using this kind of things in the knowledge representation. Okay, the same explanations, means whatever we have discussed, we will try to see in a clear way. So what is propositional logic is? It is a simplest form of representing the logic. So we say that in that propositional logic, all the statements are nothing but some kind of propositions. They are some kind of propositions, and we can also say that it is a technique of knowledge representation. It is a technique of knowledge representation where we are applying the logic and we are representing the knowledge in the mathematical form. And also we have mentioned that the declarative statement, means every declarative statement is also called as a proposition. Means the output of the proposition, either it can be true or it can be false. Now we need to understand, just now we discussed that, okay, by the help of the symbolic variables, we can represent the propositions. As we mentioned, it is raining as P, I am teaching as Q, okay, your students are listening as R. Like that, you can represent the propositions with the help of these variables. And what the propositional logic is going to consist of? It is going to consist of some objects, some relations. Means if I say James is intelligent, just now I discussed James is intelligent. Okay, so in this case, what happened? This James has become the object. It is an object, and this one is the relation. This one is the relation, or we can say that this is a function. So with this explanation, we can prove this one. You see, propositional logic, what it is going to consist of some objects, some relations, or otherwise we can say some kind of functions, and also logical connectives. Until and unless we use these logical connectives, we cannot able to extract the new knowledge from the existing one. So for this logical connectives, we are going to use some logical operators. Okay, let us try to see what are the different logical connectives that we can use in while representing the knowledge in the propositional logic. Okay, the propositions and connectives are the basic elements of the propositional logic that just now we have discussed. So we need to think on this particular point. The statements which are questions. So here, what are the questions we are having? A question saying that where is Taj Mahal? How are you? Where are you studying? So these things are the questions. So what I am telling is these questions cannot be a proposition, remember. If you are representing the knowledge as a general statement, so we can say that it is a proposition. It is raining, James is intelligent, James is hardworking, I am teaching. Such kind of things we can say it as a propositions. But we cannot call them, we cannot call the questions as a propositions. Why? Why? Because the propositional logic, it is going to fail. Means when you try to implement or when you try to exhibit the relationship between the objects, then the propositional logic has failed in that aspect. Why? Because you cannot come to a conclusion with the help of this propositional logic. So here what is happening? Where is Taj Mahal? Okay, right? Where is Taj Mahal is a kind of question, right? To this question, the propositions whatever you have framed will not be able to make or will not be able to give answer to this question. So representing the sentences in the form of questions, okay, in the form of questions, then we can say that they are not the propositions. The general sentences only we can say that they are the propositions. That's why we say that they are the declarative statements. But here these are not the declarative statements. They are having certain kind of question. Some ambiguity is there to represent the knowledge. We don't know. If I say, where is Taj Mahal? If this question is given to the artificial intelligence machine, it may or may not give the answer. If you represent the knowledge in the form of the propositional logic, definitely we can say that the AI machine is not going to give the answer to this one. Why? Because you never mentioned any relationship between the objects. Means propositional logic failed in that particular aspect, showing some kind of association among the objects. So in this point only, we need to study the concept of predicate logic. So these are the standard logical symbols what we are going to use. Just now we discussed about this one, which is called as conjunction or the logical and. Logical or, logical implies, right? Otherwise we can use this material implication also, implies. This one is implies, and negation not, for all, and there exist. For a particular instance we are going to use there exist. If it is all, we are going to use this symbol called as for all. Means we can say that these are all the logical connectives which are going to connect or which are going to show some kind of association between the objects or between the sentences when you are using these things in the predicate logic. Okay, all these things are not possible in using to use in the propositional logic representation. Let us try to see some examples and we will understand how these are possible or how this can be used in order to represent the knowledges in the predicate logic. Representing the facts. Okay, of course we have not entered into the predicate logic concept, still we are in the propositional logic concept itself, but we will try to see some more examples and we will try to understand very clearly what this propositional logic is and how it can be used to represent the facts. Why? Because just now we mentioned that propositional logic is going to help us to apply some logical rules. Okay, the fourth element. Okay, the fourth element. What is the third element? What is that? Inference mechanisms. What the inference mechanism is doing? It is making us to apply some logical rules to the knowledge what you have represented in the knowledge base. So first of all, for that one, we need to understand first of all how this fact looks like. What we can say, which things we can say it as a fact. So if you say there is a sentence called as it is raining, simply you can mention it as raining. Okay, this is a kind of representing the fact. Okay, what is this declarative statement you are having? It is raining. So how you are representing it as simply raining. Similar to that one more example is also there. It is sunny. So simply I can write sunny. Okay, right? It is windy. So I can write as it is windy. In the previous session, I have taken one example, right? What is that example? For example, okay, I can take the example like this. You see, Sita is a girl. Sita is a girl. So this is entirely different with this particular statement. Remember. So if it is this statement, so what is happening? This one will become the object. Sita will become the object, and this one will become the relation. Okay, it will become the relation, or it will become a function. So generally, we used to say we used to use a particular word called as is a. Means here what is happening? Is a is going to work as a relation for us. Okay, right? I can mention like this: Sita, okay, comma, girl. how you are predicating, you see, Sita is a girl. Okay, means this kind of representations we are not going to see further. Okay, we are trying to simplify the knowledge representations by using this logic or some logic languages. Okay, that's why if it is raining, I am saying simply it as raining. I am not saying as is raining. It's not necessary. They are the general words. It is sunny, simply sunny. It is windy, simply windy. Now you try to see this one. I have generated a new knowledge from the existing knowledges, from these three existing knowledges. So what I am telling, if it is raining, then it is not sunny. Okay, if it is raining, then it is not sunny. What happens if I remove this word? Okay, so how it will be? It will be like this. Raining. Okay, what this raining is implies? Raining implies to what? Sunny. So simply I can mention sunny. This is a simple way of representing the fact here. But here what is happened? There is a specific word called as not. Whenever it is not, even we have seen in the previous example to use the symbol called as not symbol. So how we have represented the knowledge here, the fact here like this. Raining implies not sunny. It's not necessary to use the word again not here. Why? Because here not is the connective. For this connective, we can use the logical operators. We will try to see some more examples. Socrates is a man. Okay, with the experience of the previous slide, you can simply write this Socrates as a man like this. Socrates man I can write. Okay, why? Because just now I said that I should not supposed to use easy. Okay, so simply I represented Socrates is a man as Socrates man. Similar to that one more sentence is also there. What is that? If Plato is a man. So with this same kind of representation, I can mention this one as Plato man. Okay, so we will try to see this one. We have improvised, means whatever the things we have seen in the previous case, that we try to improvise with the help of this representation. So what I have done, I have represented like this, man, Socrates. So who is Socrates here? Socrates is a man. Means this man is telling about the relationship or a relation of all about the object called as Socrates. Similar to that one, man, Plato. Socrates man, you can represent it is that we have improvised and we have written in this manner. Man in the brackets, Socrates. Man, Plato. But we will try to see one other case. There is a sentence called as all men are mortal. So simply with this example, you cannot write that men mortal. Men mortal. You should not supposed to write like this. Why? Because if you mention like this, what happens is you are failing. Means you are unable to identify the association or the connectivity between the men and mortal. Okay, why? Because one more thing is also came here. In this particular case, we are talking about a specific person. Either it is Socrates or it may be Plato. But in this case, we are talking all about the men. Okay, when it is all about, you should supposed to use this kind of thing. Okay, right, for all. Okay, but here what you have done with the previous knowledge, simply I mentioned it as men mortal. This kind of representation is always wrong. Okay. Coming to the propositional logic, just now we discussed that the propositional logic, it has failed. Okay, it has failed in capturing the relationship. If it is a case, means if the propositional logic is not able to identify or represent the association between the objects, then how can we do it? So the very primary question that comes in our mind when this propositional logic fails is this one: how can these sentences be represented so that we can infer the third sentence from the first two? Okay, and also the propositional logic, it is going to commit. It is going to commit only to the existing of facts. Okay, existing of facts, and that may or may not be belongs to a particular world. Means some sentences may relate to one specific world and some sentence may relate to another kind of world. Cricket may be one kind of world, games may be one kind of world, sports may be another kind of world. Means in this case, what is happening? We are saying that this propositional logic, it is committed only to the existing one, only to the existing facts. It is not going to concentrate on implementing or generating the new facts. But only one best advantage we have with the propositional logic is its syntax is simple, and we are having a simple semantics. Means the grammar we use for representing the knowledge is simple, and also we will able to get very good and meaningful sentences from the existing one. Okay, these explanations are making us to move or to think towards a alternative. So what will be the alternative for the propositional logic is, okay, propositional logic, just now I mentioned that it is failed in showing the relationship between the objects or showing the relationship between the sentences. Okay, all men are mortal, right? Means it failed to represent or show the relationship between the men and mortal. So if it is the case, then we cannot use this propositional logic in order to generate some inferences. For this specific reason, we are looking into another important language of logic, which is called as predicate logic. Okay, so we will discuss more clearly about what this predicate logic is. Of course, this predicate logic is also sometimes called as first order logic. Okay, we will try to see more clearly about this first order logic or predicate logic in the coming session. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.